Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're going to talk about metrics and the concept of matrices, and I'm going to give a quick overview in this video. In the subsequent videos, I'm going to talk about the other types or other calculations in matrices, where we talk about things like how do we find the determinant, how do we find inverse of a matrix, and how do we find so many other things. How do you add and subtract matrices? We'll talk about all those as well. But in this video, I just want to introduce the concept of metrics here and talk about it just briefly to give us a quick idea, especially for those that have not solved questions on matrices before. All right, before I proceed, don't forget to like, share, and subscribe. If you've not clicked notification bell, I don't know what you're waiting for. Please do that so that when I post new videos, you'll be the first person to know. So basically, when we talk about the metrics, we have basically usually two types of metrics. Usually we have the real metrics and the complex metric. So what differentiates both of them is the set of numbers that it contains. So for instance, if it contains a real number, it's going to be called a real matrix. And if it contains a complex number, it's going to be called a complex metric. So basically, I can say a matrix is a set of real or complex numbers, but the key thing here is that they are arranged in rows and columns to form a rectangular array, okay? And when they are being arranged in these rows and columns, the numbers in this matrix form are called elements, all right? So you have, let's assume we have a particular metric. So they are arranged in rows and columns. So you can have A, B, C, D, E, F. So you can see the numbers in each of these are called elements. So this is an element, that is an element, okay? And you can see they are arranged in a rectangular array, all right? So because I'm aware students do take notes, I'm going to write down what I just said so that you can take notes of it. So basically what I said was that a matrix is a set of real number. Okay. So real number. So if it's real numbers, it's going to be called a real matrix. Okay. Or complex number. So if you have a complex numbers in the matrix, it's going to be called a complex matrix. Okay. So these numbers are arranged, all right? They are arranged in rows and columns. So to form a rectangular array. Okay. So for instance, so we have A, B, C, and we have D, E, F. So for instance, we have numbers like this. So it's a metric. So in order for me not to confuse students, I would prefer to use some numbers now. So just to make it easy. So if I have real numbers now, so I can have, for instance, I have 3, 5, 7, 8, 12, 6, 2, 8. Are you seeing it? This is a matrix, okay? You can see it's a real matrix because it has real numbers, all right? Okay, so in this video, I'm going to focus on the real matrix. So because it has real numbers, it's going to be called a real matrix. So in this video, I'm going to talk about real matrix only. Okay, in the subsequent video, I will talk about complex numbers and we'll talk about how you can put that into complex metrics. But I'm going to focus on real metrics in this video, okay? So another thing again that I said is that the numbers themselves are called elements. So for instance, 8 is an element, 3 is an element. So all these numbers in here are called elements, all right? So You need to keep that in mind. So all the numbers there are called elements. So I'm going to write it down. So because I know students do take notes from what I put on the board here. So we have that. So we're going to go down. So we do this. So we have, so the numbers themselves are called elements. The numbers themselves are called elements of that matrix. Okay? So like in this example, we have 3 is an element, 7 is an element, 12 is an element. So each of these are called elements. Now, under the elements, there are different terminologies that you encounter. So if you're talking about elements, all right, when you're solving in the textbook, you will notice that you'll talk things like, you see things like what we call the diagonal element. Okay, so you see things like the diagonal elements. You also see things like main diagonal, or you can say things like leading diagonal. You see things like upper diagonal element. You see things like lower diagonal element. So you'll be seeing terminologies like this. So you see things like upper diagonal element. Okay, and you see things like lower diagonal element. Okay. So you'll be seeing stuff like this. So we're going to talk about this quickly, all right? So that because I know some of us is the first time we're meeting or interacting with these terminologies here. So I'm going to start with the diagonal element. So the diagonal elements of a matrix is usually in a square matrix. Are the elements that are located on the diagonal of the matrix. So basically from the top left corner all the way to the bottom right corner. So what I'm saying is, if for instance we have, let's say we have 4, 5, 6, 8, 9, 2, 3, 8, 7. Let's assume this is a 3 by 3 square matrix. I'm going to explain that. Now, when we talk about a diagonal elements are all the numbers in this diagonal here. So the diagonal elements are going to be 4, 9, and 7. This is what we call a diagonal element, all right? So because I know students do take note, I'm going to write this down so that it will make sense to you. So the thing we have here is that the diagonal element, so diagonal elements of a matrix. So now this for this is usually in a square matrix. I'm going to talk about this very soon. So usually a square matrix. Okay, usually a square matrix. So the diagonal element of a matrix, okay, are those elements or are the elements all right? So these are the elements that are located on the diagonal. So the keyword, they are located on the diagonal of the matrix, okay? So the keyword is diagonal of the matrix. So basically, it's from the left top or from the top left. So from the top left corner to the bottom right corner. Okay, so like I said earlier, if you have numbers like this, -2, 5, 7, 3, 8, 1, 4, 6, 2, for instance. Now the diagonal of that matrix, so the diagonal, when we talk about diagonal, we're talking about all the numbers from the top left corner here to the bottom what? Right corner. And this is what? These are the diagonal elements. So the diagonal elements here, okay, in this example, the diagonal elements will be -2, 8, and what? 2. So all the numbers that are in that diagonal is called the diagonal what? Elements, okay? Now, also, there'll be some other terminologies you will also encounter, all right, in addition to this. Now, the first thing you're going to see is that you're going to hear something like leading diagonal or main diagonal. So these are elements, when we talk about leading diagonal, so these are elements that are similar to diagonal elements. Okay, so when you say leading diagonal, they are the same thing as the diagonal elements. Okay? All right, so that is it. So some textbook will call diagonal elements. All right, so the diagonal elements is the same thing as the what? You see it as the main diagonal. Which is the same thing as the what? Leading diagonal. So that means that's not what we have here. We can call the diagonal element the same thing as main diagonal or leading diagonal. So it varies. So in some textbook, they'll call it, you see it like the main diagonal. In some textbook, you see something like the leading diagonal. In some textbook, you will see things like diagonal element. They are the same thing. Okay? So the diagonal element is also the same thing as the main diagonal, same thing as the leading diagonal. So that means we can now say the main diagonal of that matrix is -2, 8, and 2, or you can say the leading diagonal is -2, 8, and 2. All right, good. Now, how do you represent it? So usually we have the diagonal, we represent it using the what? Diag. So you see things like diag, okay? So when, for instance, you see diag, it means that we're talking about the diagonal element. Okay, so it's either we're referring to the diagonal element or we're referring to the main diagonal or we're referring to the what? The leading diagonal. So for instance, okay, let's pick a quick example. So if we say we have a matrix A, okay, matrix A is equal to, let's say we have it as 5, 2, 8, and 7. 5, 2, 8, and 7. And if I now tell you that find diag A, so that means, why is it writing like this? Diag A, okay? So diag A, I'm referring to the diagonal of this. So in this example, the diagonal is going to be 5 and 7. All right, so diag A is going to be 5 and what? 7. All right, So now I've explained the concept of diagonal of an element, all right? Now the next thing I'm going to talk about now, I want to talk about the upper diagonal and the lower diagonal. So basically, when we say the diagonal of an element, so it divides it from the top left or to the bottom right. Now, all the elements in the upper part is called the upper diagonal, and all the elements in the lower part is called the what? Lower diagonal. So for instance, in this example, the upper diagonal is going to be all the elements here. So this is going to be the upper diagonal, and all the elements here is going to be the what? The lower what? Diagonal. All right. So that means if we now have a particular matrix, so let's call it particular matrix anything. So let's say we have uh, matrix B, okay? And matrix B, let's make sure, let's say it's a 4x4 matrix. I'm going to explain the concept of the 4x4, 2x2. We'll talk about that later. But let's assume we have this particular element here, 7, 3, 2, 7, 3, 2, 8, 1, 3, 4, 7, minus 1, minus 1, 2, let's say 3, 8. Let me make this one 13. And this one is 15, 6, 2, 3. Let's assume we have matrix B like this. It could be anything. All right. So now we've already agreed that the diagonal elements are going to be all this here. All right. So these are the diagonal elements here. So all these numbers here are the diagonal elements. So you can call it the main diagonal. So you can call it the main diagonal, or you can call it the leading diagonal. Okay, and all the numbers here, 7, 3, 13, and 6 are the diagonal elements. So we can now say for sure therefore the diagonal elements or the main diagonal, all right? So diagonal elements in matrix B, or you can say diag B is going to be equal to 7, 3, 13, and 6. All right. Now, but that's not what we were talking about here. We discussed this earlier. But what we want to tell you is that we're talking about the upper diagonal, all right? So the upper diagonal are the numbers that are here, that are above the diagonal. So these numbers here, so this is what we call the upper diagonal elements. And this number here okay, this is what we call the lower diagonal elements. So in the previous example, the upper one, okay, it's not going to, sorry, I beg your pardon, I think I drew this wrongly. So the upper one is going to be this one, this way. So this is going to be the upper one. So the upper diagonal element. All right. Then this one at the bottom here, this number here, 5 and 1, are going to be the lower diagonal what? Elements. So we can then move on to this. So therefore, in this example, then the upper diagonal element, so the upper diagonal, will be equal to 3, 4, and 8. Then the lower diagonal elements will be 1 minus 2 and what? 15. So now, if we can say this, so that means we can now define both of them then. So we can now say the upper diagonal elements are the diagonal above. So the upper diagonal elements now will be the diagonal above the main diagonal, and the lower diagonal elements are the diagonal below the main diagonal. All right? So the upper diagonal elements, so for those that are writing, are the elements, all right, in the diagonal just above the leading diagonal. Okay, so like that example, so we had 3, 8, 2, 1, 6, 4, 8, 1, and 3. Okay, so in this example, here, this is the main diagonal. So therefore, the diagonal element here is going to be, the upper diagonal will be 8 and 1. So this is going to be the upper diagonal element. Okay, so therefore, will be what? 8 and 1. Now, the same thing we can also write for the lower diagonal elements, but in this case, the lower diagonal elements are going to be the elements in the diagonal just below. Does that make sense? So it's going to be the element just below. So the lower diagonal element the lower diagonal element are the elements in the diagonal now in the previous one was just above, or in this case is what? Just what? Below the leading or the main diagonal. So in some cases, you have it as, so we call it the leading, some we call it the main, it's still the same thing, all right? So if we look at this example, let's look at that example we had. We had 3, 2, 3, 2, and 6, 8, 1, and 4. We have 8, 1, and 3, okay? So the leading diagonal is going to be this one here, okay? Now, but in this case, the lower diagonal are just the element just below it. So this is going to be the lower what? Diagonal. So the lower diagonal element here is going to be what? 2 and 4. Okay? So that is it. So that is it. So that is how you talk about the leading diagonal, the upper diagonal element, the lower diagonal element, and I've introduced the concept here. All right, good. Now let's go to the next part here. The next thing as well is that I'm going to talk about that how do you arrange matrices. So basically, matrices are usually arranged in rows and columns, as you can see. So usually it is like the m rows and n columns, all right? But how do you represent it is called the m by n or m multiplied by n, but you don't say m multiplied by n, you say m by n matrix. So this helps you to determine the order of a matrix. So in some textbook, they will ask you, okay, what is the order of this matrix? You hear people say it's a 2x2 matrix, a 3x3 matrix, a 4x1 matrix, a 4x1x4 matrix. So all these terminologies is what we want to talk about now. So let's assume we have a particular matrix, okay? Let's assume we have a matrix. So just for me to be sure that we are all on the same page, all right? So I'm not assuming any knowledge. So before we go further, when I talk about rows, okay? Rows, it means we're talking about in this direction. Is that okay? This is what we call rows. And when we talk about columns, okay? And when we talk about columns, it means I'm talking about in this direction. So for instance, if I have 3, 2, 1, 8, 3, 4, something like this, okay? Now, how many rows do I have here? You can see I have, oh, sorry, let me move this one. So how many rows do I have here? So for the rows, I have 1 and I have 2. So that means the number of rows in this matrix is 2, all right? Now, the same thing, how many columns do I have here? All right. So you now have to look at this carefully. So columns is in that direction. So we have 1, we have 2, and we have 3. So that means the number of columns we have here is equal to 3. So that means in this matrix, we have 2 columns. So we have 2 rows and we have 3 columns. All right. So let's pick another example. So the reason why I'm doing this is because I'm teaching a very large audience and I'm want to be sure that everybody are in the same page with me as I keep moving down the video series. So let's assume we have this 3, 4, and 7 as a particular matrix. Now let us check how many rows do we have, okay? The rows we have 1, we have 2, and we have 3. So that means the rows here we have is 3. Now the next part now is how many columns do we have? So if you look at this, think about it carefully, you will see that the columns we have here, we just have only what? 1. Are you seeing it? So therefore the number of columns we have here is what? 1. You just have 1 column and 3 rows. So let me just pick one more before I go to what I wanted to talk about. So if we have something like this, 4, 5, 7. All right, so 4, 5, 7. How many rows do we have here? We just have what? 1 row. Okay, you have only 1 row. Now, how many columns do we have here? So we have 1, we have 2, and we have 3. Are you seeing it? So that means in this case, we have 3 columns. Good. Now, so let's go back to how do we talk about the order of a matrix. So now we know how to talk about rows and column. We can talk about the order of a matrix now. So let's talk about the order. Okay. Let's talk about how do you denote metrics, okay? So let's write it as denotation of matrices. So now, let's assume that the matrix, okay, a particular matrix, like what we talked about earlier, let's say it has having m rows. So we don't know the number of rows. The rows can be 5, 10, 20. It does not really matter. And it has what? N columns. So the number of columns it has is n columns. Okay? So m rows and n columns. So, and this is called an m by n matrix. So you can see. So that means when you're writing it, it's going to, the m is going to be in front. So the number of rows is going to be in front and the number of columns is going to be in front. And how do we say it? We say it as M. So it's said as M by N. That's how you pronounce it. So it's not M multiplied by N. It means M by N. And we use this to determine the order. Okay? We use this to determine the order. So for instance, we're going to have, if for instance, you have a 2 by 5 matrix. So what this means is that the number of rows in this matrix is 2, and the number of column in this matrix is what? 5. Now let's go back to that example we had earlier. So that means for the first matrix, how am I going to write this? Now I'm going to write this because I know the number of rows here is 2, the number of columns. So this is going to be a 2 by 3 matrix. So that means this matrix here is a 2 by 3. So that means when I'm writing it and I write 2 by 3, anybody will understand that what I'm talking about, that the matrix I'm talking about has 2 rows and 3 columns. In this other example, what do you think it should be? Remember, the rows must come first, okay? The rows must come first. So this is going to be a what? A 3 by 1 matrix. So a 3 by 1 matrix, it means that the number of rows we have here is 3, and the number of columns we have here is 1. Now, when you go to the next one, in this one, it's going to be what? What do you think? Definitely, it's going to be a 1 by 3 matrix. So because the number of rows we have here is 1, and the number of columns we have here is what? 3. Okay, good. So that means now we can now make some combination of things now. So we've already learned the concept of elements, and we've learned the concept of rows and columns. So let me give an example now. So assuming we have this matrix. So remember I said matrix is usually written within a bracket. So you write the elements within a square bracket. So let me just write this down. So just in case a student didn't catch it the first time. So a matrix is indicated, okay, by writing the array okay, by writing why is it so, by representing, okay, by representing the array within brackets. Okay, by representing the array within brackets. So for instance, let's assume we have this. We have 2, 5, 10, 6, 2 minus 1, for instance. Now, if I ask you now to define or explain the order or talk about this matrix, so you will say how many rows this has? This has 2 rows, right? It has 2 rows because it has 1 and 2. So that has 2 rows. And how many columns? So we now have to check how many columns as well. So for the columns, it has 1, it has 2, and it has 3. So it has 2 rows and it has 3 what? Columns here. All right, so it has 3 columns. So that means this is going to be a 2 by 3 matrix. Okay, so it's a 2 by what? 3 because it has 2 rows and 3 columns. But when we're talking the elements of this matrix, so if it's the elements, so although it's a 2 by 3, it has how many elements? It has 6 elements. So it has what? 6 elements. Are you seeing it? And the elements are 2. The second one is 10. The third one is 2. The fourth one is 5. The fifth one is 6. And the sixth one is -1. Are you seeing it? So these are the elements in this matrix, but it's a 2 by 3 matrix. Okay. Now we know how to talk about or denote a particular matrix. The next thing we need to talk about is the size of a matrix. So basically, the size of a matrix is defined by the number of rows and columns it contains. So when we're talking about the size of a matrix, it's basically the number of rows and columns it contains. And usually, what happens is that there is no limit to the number of rows and columns a matrix can have. So you can have a matrix that's 100 rows and 100 columns. You can have a matrix that is 3 rows and 2 columns. You can have a matrix that is 1 row and 1 column. Does that make sense? Or you can have a matrix that is, 1 row and 2 columns. You can have a matrix that is 7 row and 20 columns. So it does not really matter, provided that this matrix, the numbers are positive integers. Is that okay? So that means, let me write this down because I know students will take notes. So what I just said is that the size, so now I'm talking about the size, all right? So the size of a matrix is defined by the number of rows and columns it contains. Okay, so the size of a matrix is defined by the number of what? Rows and columns it contains. All right. So, and I said that there is no limit to the number of rows and columns a matrix can contain. All right. So there is no limit to the numbers of rows and column a matrix can have. Okay. So there is no limit. It can be 3 by 5 and it can be 20 by 6. So far, it is a positive what? Integer. All right. As long as they are positive what? They are positive integers. Okay. So what I'm saying is that you can have, for example, you can have a 2 by 50 matrix. You can have a 100 by 300 matrix. It does not really matter. You can have a 1 by 2 matrix. You can have a 2 by 1 matrix. You can have a 70 by 85 matrix. It does not really matter. There is no limit to the number of row and column a matrix can have in the usual sense. Is that okay? All right, so I think I've pretty much covered the basics that we need to proceed to start solving, okay? I think so. All right. Let's see. I'm going to talk about some concepts now, okay? So let's see some concept that I'm going to talk about. The concept I'm going to talk about in the remaining part of this series. So there'll be some concepts I'm going to talk about. So the first one is that I'm going to want to talk about the types of metrics. So I will want to talk about the types of metrics and how do we find that. So how do we talk about the types of metrics? So in some textbook, you will see things like identity metrics, square metrics, inverse of a matrix, unit matrix. So all those types of metrics, I'm going to talk about it. So the first thing I'm going to talk about the types of metrics. So we're going to talk about the type of metrics. Then number two, we're going to talk about the matrix arithmetic. So I'm going to talk about how do we add, how do we subtract, how do we multiply. I'll talk about the scalar multiplication and the multiplication of two matrices. So I'm going to combine both of them. So I'm going to talk about matrix multiplication. Or let me just say matrix arithmetic. So I'm going to talk about addition and subtraction. Okay. Then I'm going to also talk about multiplication. Okay, I'll talk about multiplication, but for multiplication, I'm going to talk about two. I'm going to talk about scalar multiplication, and I'm going to talk about multiplication of two matrices. Multiplication of okay. I'm going to talk about scalar multiplication and the multiplication of two matrices. Then number three, the next thing I'm going to talk about is how to transpose a matrix. So these are things we're going to talk about in this series. How do you transpose a matrix? Then number four, when we're done with transposing, I'm going to talk about how do you find a determinant. Now, but I'm going to only restrict myself to find the determinant of a square matrix, okay? So I'm going to show you how to find a determinant of a square matrix. So we'll do that. Number five, then I will show you how to find the inverse of a square matrix. Then finally, we'll talk about simultaneous linear equation. And that's what we talk about. So these are the 6 things I'm going to talk about in this concept. So these are the several concepts I'm going to discuss. Okay? Several concepts that will be discussed. These are the concepts I'm going to talk about in this video series. So I'm going to talk about this concept. I'll talk about the types of metrics, and I'm going to talk about matrix arithmetic. How do you add and subtract matrices? We talk about how do you multiply metrics, scalar multiplication. So let me just write this here. So scalar multiplication. Okay. Then we're going to talk about how do you multiply two matrices together. Then the next one we'll talk about is how do we transpose a matrix, determinant of a square matrix, inverse of a square matrix, and simultaneous linear equation. All right. So that means the next video, I'm going to go straight to the types of metrics. Okay. This is what we're going to talk about now, the types of metrics. So it's very important that you subscribe and you click the notification bell. If you have any question and you're not really sure, just let me know and I'll get back to you. All right. So I'm going to see you in the next video where we talk about the types of metrics. And this is all what we've talked about today. So just a quick overview. I've just talked to you about, or we've spoken about the matrices. And I also told you the elements. We have the diagonal element, we have the upper diagonal and the lower diagonal. So the upper diagonal are the elements that are just above the diagonal, while the lower diagonal are elements just below. And I also told you that the diagonal elements could be the main diagonal or the leading diagonal. And in some textbook, you can see it as diag. All right. So for instance, in this matrix, the diagonal is going to be 5 and 7. And the lower diagonal will be 2, the upper will be 8. So I also gave you another bigger one. So this is the 1, 2, 3, 4. So it's a 4 by 4 matrix now. So you know this is going to be a matrix. So it's going to be a 4 by 4 because it has 4 rows and 4 columns. So the leading diagonal or the diagonal elements are 7, 3, 13, and 6, while the upper diagonal elements are 3, 4, 8, and the lower one are 1, -2, and 15. So I told you that the upper diagonals are just the elements that are just above, while the lower one are the elements just below. Then after that, I went straight to talk about the concept of finding the rows and columns. So I told you that in the denotation, the rows are going horizontally while the columns are vertically. So you write the rows before the columns. So if you have 2 rows and 3 columns, it's going to be a 2 by 3 matrix. But the elements are different. The elements are the numbers that within the matrix. And I also told you that the size of matrix is defined by the number of rows and columns it contains. All right. Then I also told you about the concept I'm going to talk about in this video series. I'm going to talk about the types of matrix, the matrix arithmetic, how to transpose, determinant of a square matrix, inverse, and simultaneous linear equation. So the next video, we're going to talk about how do we do the types of metrics. So don't forget to subscribe and click the notification bell. So when I post the next video, you'll be the first person to know. See you soon.